So hello friends, today we are going to study the exercise 1.4 of the chapter real numbers, and now we have theorem number 1.6 before the exercise, that is, let p be a prime number if p divides a square. If p divides a square, then p divides a too. Means if p divides a square, where p is a prime number, it divides a square, then it will divide a also, where a is a positive integer. So let us take the value of p 2, right? We have taken the value of p is 2. Then what we can take? A square. In a square we can take 4. If we take a square 4, then what will be the a square root of 4? That will be 2, right? Now this p is dividing a square, that is 4 by 2 equals to 2. Then p also divides 2 also, right? Now let us take p value 2 only. We can take the a square value as 9. What the value of a square is 9, then the value of a will become 3. See here, p is not dividing a square and it is also not dividing a. It is not dividing a square, it is not dividing a. Here it is dividing a square, here it is dividing a. So means if p divides a square, then p divides a also. If p doesn't divide a square, then p doesn't divide a also. So let us change the value of p, that is 3. Here we take as a square equals to 81. Here a will become 9, right? Here 3 is dividing 81 and it will also divide 9. So here we can take again 3, here we can take 16. A square 16. Then what will a become? A will become 4. 3 is can't divide 16 and it can't divide 4 also. So you have seen the same scenario here. If p divides a square, then p divides a also. Okay. Now we are going to see the exercise problem, that is, prove that the following are irrational. We have to prove that the following given numbers are irrational. So we have 1 by root 2. So in this exercise we have to remember one word, that is contrary, which means opposite. Opposite to something, opposite to direction, opposite to anything means contrary. So now what we do is, we have 1 by root 2. So what we take? On the contrary. On the contrary, let us suppose that 1 by root 2 is a rational number. Then what will happen? 1 by root 2 will become a rational number in the form of p by q, right? 1 by root 2 will become a rational number in the form of p by q, where p comma q not equals to 0, right? If q is equals to 0, then it will not be a rational number. So now what we do? We reciprocal them. How? Root 2 equals to q by p. Root 2 by 1 equals to q by p. So here we have this root 2 by. Now we have seen that root 2 by 1 equals to q by p. Therefore root 2 is a rational number, right? But this contradiction arised because we have supposed that 1 by root 2 is a rational number. But this contradiction arised due to the supposition that 1 by root 2 is a rational number. So therefore we have thought that it is a rational number, so we have got the result as rational number. If we because it is a irrational number, then therefore 1 by root 2 will be or is an irrational number, right? We have taken the contrary here. We have taken opposite, that it is a rational number. So we have got the result as rational number. So opposite to the result we have got, that is positive. Now what will be the opposite to the positive? That will be negative, that is irrational. We have taken positive as our contrary, but we have got negative. That means it is an irrational number. Okay. Now let us look at the second one, that is root 3 plus 5. So if you have not understood this concept by the first one, so listen properly. The second one, this is for you. So what we have given, prove that the following are irrational. They are already irrational. Just we have to prove that they are irrational. So now we have to take contrary. Contrary means opposite. So contrary. So by contrary means we have taken opposite to it. Let us suppose root 3 plus root 5 is a rational number, right? By contrary, let us suppose root 3 plus root 5 is a rational number. So what means a rational number? The number which is in the form of q by p by q. So root 3 by 5. So here root 3 plus root 5 equals to p by q. So now we can't solve it directly. So square on both sides. Square on both sides. So root 3 plus root 5 whole square equals to p by q. P square or q square, right? P square or q square. So what will be a plus b whole square? That will be a square. That is root 3 whole square will be 3. Root 5 whole square will be 5 plus 2 root 3 into root 5. That will be root 15. 3 5s are 15 and root upon. That equals to p square by q square. Okay. Then we have to add this, that is 8 plus 2 root 15 equals to p square by q square. Now here 2 root 15 will be p square by q square minus 8. Okay. So let us solve that here. So 2 root 15 equals to p square minus 8q square by q square. Then root 15 will be, it is in the multiplication here, then it becomes into denominator, that will be 2q square. So here numerator is same and in the denominator we are just multiplying it by 2 here. So root 15 is in the form of p by q and therefore it is a rational number. So I'll write here only. Therefore root 15 is a rational number. Rational number. But this contradiction arised. This contradiction. See, you have to write these statements in the examination. But this contradiction arised due to our supposition of, or we have supposed that root 3 plus root 5 is a rational number. We have supposed that it is a rational number. We have supposed because we have taken it as opposite in the due to contrary. So due to contrary means opposite we have taken. We have taken the opposite of root 3 plus 5, that is it is a irrational number, but we have taken it as rational number. So we have got the number result as rational number. So we have done the opposite way. So the result will be, therefore root 15 is a irrational number. Right? You have written this, we have taken the opposite, so we have got the rational. So we are doing this opposite also, that is root 15 is a irrational number. Therefore root 3 plus root 5 will also become a irrational number. So we have proved that root 3 plus root 5 is an irrational number. Hence proved. I'll explain you once again. That is root 3 plus root 5 is the given number. We have to prove that it is an irrational number. It is already given that it is an irrational number. Just we have to prove it. So we are taking contrary. Contrary means opposite. Contrary means opposite. We have taken the opposite, that root 3 plus root 5 is a rational number. So what a rational number is, that is it is in the p by q form. So root 3 plus root 5 is in the form of p by q. So now we are going to solve. So SOBS, that is square on both sides, that is root 3 plus root 5 whole square equals to q square by p square by q square. Then a plus b whole square formula, that is a square plus b square plus 2ab. 3 plus 5 plus 2 root 15, that equals to p square by q square. So now we are adding this 3 plus 5, that we get 8, and we have 2 root 15. So and we have your p square by q square. So we send this 8 to the RHS, that will become minus 8. So 2 root 15 equals to p square by q square and minus 8. So here we are cross multiplying, that is LCM, that will be 2 root 15 equals to p square minus 8q square by q square. Okay, and here root 15 will become, this 2 will go into the denominator, and we will get root 15 equals to in the form of p by q. We have a numerator and we have a denominator, therefore it is a rational number. But we have assumed that root 3 plus root 5 is a rational number. That is the reason we got it in the form of p by q. So this contradiction arised due to our supposition. We have supposed that it is a rational number. That's why we got root 15 as a rational number, but it is an irrational number. So we have to opposite the result. Then we can say that root 15 is an irrational number. So root 15 is an irrational number. By that, root 3 plus root 5 will also become an irrational number. So hence proved. So now let us solve the fifth problem, that is 3 plus 2 root 5. It is given that it is a irrational number, but we have to prove that. Okay, I am skipping the third and fourth one because they are the similar ones to the second, and it is also a similar one, but I am showing it because it has 2 root 5 here and it is a real number here. So therefore let's start that. So let us contradict. Let us by contrary. Contrary means opposite. Suppose that 3 plus 2 root 5 is a rational number. Okay, then what will 3 plus 2 root 5 will be equal to? As a rational number, we know that a rational number should be in the form of p by q. So p by q, right? 3 plus 2 root 5 is in the form of p by q, where q is not equals to 0. So then 2 root 5 equals to p by q. Here we have 3. We will send it to RHS. It will become negative and minus 3. Okay. So 2 root 5 equals to. So we have to equate the denominator here. So that will be 3q by q. So we will multiply this q in the numerator and denominator. So then we will have root 5 equals to p minus 3q by 2q. So here we have 2 into root 5. So what we are doing, we are sending this 2 to the denominator here. So then we have root 5 equals to p minus 3q by 2q. So root 5 is in the form of p by q, right? Therefore, it is a rational number. Root 5 equals to p by q is in the form of p by q, therefore it is a rational number. But here I'll write it, but it contradicts the fact that root 5 is an irrational number. The fact is that root 5 is an irrational number, but it contradicts. It is the opposite to it. We have written is root 5 is a rational number. It is opposite to the fact. That's why we are writing, but it contradicts the fact. So therefore, we have supposed that is 3 plus 2 root 5 is a rational number should be contrary, right? It is an contrary. So therefore, root 5 is an irrational number. Because we have got root 5 is an rational number, but it is an contradict, it will become a irrational number, due to which we will get that 3 plus 2 root 5 will also be an irrational number, because we have got the result as rational number here. We have taken the opposite, we have got the opposite answer. So what will be the correct answer? Rational number. So 3 plus 2 root 5 is an irrational number. We have got the answer as rational number. So opposite to the rational number, we have irrational number. So we are writing it as irrational number. Therefore, hence proved. Say, I'll explain you once again. We have taken the contrary, that we have given that it is an irrational number, but we have taken the contrary, means opposite, that 3 plus 2 root 5 is a rational number. So 3 plus 2 root 5 will be in the form of p by q. P will equate with p by q. So 2 root 5 equals to p by q minus 3. We have 3 plus, we have sending it to RHS, it will become minus 3. So 2 root 5 equals to p minus 3q by q. So we will send this 2 to the denominator of this p by q. So root 5 equals to p minus 3q by 2q. Okay. Then we have root 5 equals to p by q. It is in the form of p by q. Here p minus 3q by 2q, right? It is in the form of p by q. So therefore we can term it as a rational number. But it contradicts the fact that root 5 is a irrational number. We have taken the contrary. So we have got the answer as rational number, but in the real it is an irrational number. So we have to write the opposite of this result. So we have written root 5 is an irrational number, due to which 3 plus root 5, 2 root 5 is an irrational number. Therefore, hence proved. So now the second bit that we have in the exercise 1.4, that is prove that root p plus root q is an irrational number where p comma q are primes. Here p and q are given, that is p comma q are two numbers that are prime numbers. So we have to prove that root p plus root q is an irrational number, right? So now prime numbers. What are prime numbers? Prime numbers are the numbers which have their factors as 1 and themselves, right? So now you take a prime number, that is 13. 13 is a prime number. 17 is a prime number, right? And 11 is a prime number. So on, we have many prime numbers. So let us take this 13 and 17 only, because we have familiar with them. So 13, what are the factors of 13? 1 comma 13. 17, 1 comma 17. So they have only factors that themselves and 1. So this type of numbers are always irrational. The root of this number, that is root 13 plus root 17, will always be an irrational number. The root of prime numbers will always be an irrational number. Okay. Now you take a not a prime number, you take a natural number, something like you take 12, you take 14, or you take 25, or you take 36. These are direct squares numbers, so we'll take 12 and 13. So root 12 plus root 14. So what we get? Root 12. We have factors here, so how we can write? We can write root 4 into root 3 because 12 has factors, but 13 doesn't have factors. Here 12 have factors. We can write in the multiplication form, that here we can write this 14 as root 7 into root 2, right? But we can't write 13 and 17 in that form because these are prime numbers. Prime numbers don't have factors. So therefore we can say that, so leave this all. So we can say that given P comma Q are prime numbers, P comma Q are prime numbers, hence root P plus root Q will be irrational number, right? Here not root P or root Q, here we have to write comma because we are not saying the sum. So what will be the sum of these prime numbers, square root of prime numbers? So root P plus root Q equals to, here it is a sum of two irrational numbers, right? It is a sum of two irrational numbers. So it will give us an irrational number only. So hence proved that root P plus root Q is an irrational number. So here we have completed our exercise 1.4. In the next video we will discuss exercise 1.5. Okay, right. Thank you.